Hello everyone, my name is Chad Workman. I'm an instructor here at the University of Arkansas in the Electrical Engineering and Computer Science Department, and today we're going to be talking a bit more about digital memory. From last video, we talked about an SR latch. This is a piece of digital memory that allows us to either set or reset Q. So if I click R, it's going to turn off Q. If I click set, it's going to turn on Q. And this is once again very helpful for remembering what we've been doing in digital memory, but to use this, we have two wires. We would have to build a separate combinational unit to run reset and another combinational unit to run set. And not super helpful for the way that I want to, or we want to record memory. It would be super helpful if we had a 1-bit input or a 1-wire input. And you all might be thinking that, oh, easy, very easy. The way to do this is like this. We simply connect reset and set together through this inverter. So now if my input is 1, I'm setting the circuit and reset is off. And if my input is 0, I am resetting the circuit and set is off. So let's demonstrate the circuit and see what happens. Be safe, turn off my stuff. Here's our circuit, I already built it. So this circuit is the exact same as the one before, except now I only have one input. And this input is going into an inverter here. And the way that I'm achieving an inverter, because this is just a NOR gate or a NOR chip with 4 NORs on it, I'm turning or sending this one input through this NOR gate here to make an inverter. We can make inverters by doing this. If I connect both inputs of the NOR gate together, either both of my inputs will be 0, 0, or both of my inputs will be 1, 1. It's kind of eliminating these two middle options, which makes an inverter. Essentially, if I input 0, I get a 1 out, and if I input 1, I get a 0 out. Kind of just erase these. Awesome. So let's plug this up, see what happens. There we go. Okay, awesome. Let's turn it on. And as we can see, I'm not pressing my input button or my data button, so my output is 0. My Q naught is on, but that's normal. We can almost just remove it for now. So my output Q is 0 when my input is 0, and my output Q is 1 whenever my input is 1. And you might think, yes, this is exactly what we want. But the problem is that we've kind of lost our latching ability. As soon as I let go of D, Q turns off. We now no longer have the ability to save our memory. There's no saving. Basically what we made is a very complicated wire. If I input 1 on the wire, it outputs 1 on the wire. Not very helpful. Let's use a different approach to think about how to do this. So now we have a new latch. It's an SR latch, same thing before. Here's our SR latch. Here's our first top NOR gate and our bottom NOR gate. But I've added a with enable. And this enable I achieve by putting 2 AND gates on the front of our SR latch. AND gates operate by only turning on, our output is 1, whenever I have an input of both 1, right? So let's imagine A is my enable and B is my reset. If my enable is off, so if A is 0, no matter what, the output from my AND gate will be 0. And if enable is on, so A is 1, right here, my output of my AND gate is whatever B is. So if enable is on, if reset is 0, output is 0, and if reset is 1, my output is 1. That essentially means that whenever my enable is off or 0, I get 2 zeros here, basically turning off my circuit. And if I have enable on, if reset is 1, it allows it to pass, and if set is 1, it allows it to pass. So let's plug this in and see what happens. Let's look at the circuit more in depth. So here's our circuit. Same thing as before. I now have an AND gate chip here. This is my reset and my set. And the only difference now is that I have a button down here for enable. This enable is connected to these ANDs, basically allowing me to turn on or turn off whether reset or set is able to pass through those AND gates. So let's turn it on, see what happens. Cool. As from before, our Q won the race, our top NOR gate, and let's click reset and set. So this is reset, should turn off this, but it's not. Neither of these buttons are doing anything. and they won't do anything until I click this enable button. Now that I've clicked the enable button, I can either reset or set the circuit. Works just the same before. If I reset, it turns off Q, and if I set, it turns on Q. And it remembers, so if I turn off Q, I can now click reset and set, but nothing changes. So cool, we've restored our latching ability, but now we need to get back to the point where we can put one input in. So let's combine the ideas from this and our previous circuit to see something else. So now we have a D latch. It's the same thing from before. We have our SR latch here, right there. Then we have our enable circuit, our AND gates right here connected just before our SR latch. And then finally we have this inversion stage, inverting our D to a 0 or to a 1. If our D is a 0, this inverts to a 1, either setting or resetting our circuit. So I've already built this. Let's take a look at how this one operates. Same thing from before. I'm using a NOR gate to create an inverter for my D input. Here's D, here's my enable. Let's plug this up or turn it on and see what happens. So Q is off, Q naught is on, and here's my data. So if I click data, nothing is happening. I'm not changing my output like before whenever we had the circuit that was essentially just a wire. As soon as I would turn on D or turn off D, our outputs would change and follow it immediately. Now, our outputs only follow D whenever enable is on. So I'm clicking enable, and now our outputs follow our input. D is on, Q is on. D is off, Q is off. And I can even leave it. So let's say my data is 1, and I want to save the memory in D. I click enable, and I let go of enable, and now even though my data changes, it remembers that whenever I sampled my data, it is still 1. And if I enable and my data is 0, it'll go here. Turns off, reading 0. And we can kind of just remove this as well to see that whenever data is on, it follows data if enable's on, and it follows all the time I'm holding D, or holding down enable. And if I let go of enable, my output remembers what it sampled at. Awesome. This is way more helpful for creating register files or any kind of memory whenever we're creating circuits, because now we can write to this with only 1 bit. And we have another control signal to determine whether we're reading or whether we're not reading what we're trying to save. Super helpful for the creation of computers. And with that, I hope you learned something. Thank you very much. Follow for more.